We're going to use a method called elimination to solve this system. The two methods we've used so far, we solve by graphing, and then we solve by substitution. So for elimination, we would like to have the exact same amount of x's, but one positive and one negative. Or the exact same amount of y's, but one positive and the other one negative. So see how on this one, I have positive 2x and negative 2x? That's what I need to use the elimination method. So what we're going to do is simply draw a line and add them together. And when you add these together, you're just adding straight down. So if I'm adding here straight down, 2x minus 2x is nothing. We're not going to write what we don't have, only what we do have. So 2x minus 2x is nothing. Then let's move that over. Negative 5y plus 10y's. That makes 5y. Okay, then let's bring down the equal sign. Okay, moving this arrow over here. We're going to do 6 minus 16. And so that is negative 10. And hopefully you can see why this is called the elimination method, because see how the x's were eliminated? To finish solving this, I'm going to get rid of multiply by 5. So I'll divide both sides by 5. Y is now by itself, and negative 10 divided by positive 5 is negative 2. Now that I know y, I can go back into either one of the original equations. It doesn't matter if you use the top equation or the bottom equation. You just grab one of those equations. So for no particular reason, I'm just grabbing the top one, but it would have been fine to grab this one. We're going to substitute into this equation the number negative 2 for y. So instead of y, I'm going to put in negative 2. Now we want to solve this equation. Before we can start moving letters to one side, numbers to the other, we want to simplify. And if we simplify, we can take negative 5 multiplied by negative 2, and we get positive 10. We want to bring down the 2x and bring down the equals 6. Now that I've simplified the left side, I'm ready to move letters to one side, numbers to the other. So I have letters, numbers, numbers. Let me move this positive 10 to the other side by subtracting 10. What I do to one side, I do to the other. The 2x is still over here on the left side. Bring down the equal sign. 6 minus 10 is negative 4. And then finally, to get x by itself, I want to get rid of multiply by 2. So I'm going to divide by 2. Negative 4 divided by positive 2 is negative 2. So my solution is x is negative 2 and y is negative 2. If we would solve by graphing, we would notice that when we graphed both of these original lines, they would intersect at the point negative 2 comma negative 2. The key, one more time, is see how they were opposites, 2x and negative 2x? So they eliminate each other. And it doesn't matter if it's the x's or the y's. So let's look at one more example. This time, I have positive 6x and positive 6x, 9y and 5y. They're not exactly the same, but opposites. If I do 6x plus 6x, I get 12x. they're not going to eliminate each other. So I need one of those to be a negative. I'm going to take one of the equations, either the top one or the bottom one, and force the 6x to be a negative 6x. And to turn a 6x into a negative 6x, we multiply by -1. Okay, it doesn't matter which equation I decide to do this for. For no particular reason, I'm just doing it to the bottom one. I'm going to multiply the left side of this equation by -1 and the right side of the equation by -1 to accomplish making that negative 6x. So let's go ahead and come over to the side here for this one. -1 multiplied by 6x, whoops, my bad, is negative 6x. -1 multiplied by 5y is negative 5y. -1 multiplied by 9 is negative 9. Okay, guys, so far so good. We just turn that into a negative 6x. Okay, the top equation, I'm just going to bring straight across because I'm not doing anything to it. 6x plus 9y equals -3 is still the same equation. But what we've accomplished is now these are opposites. We had one extra step in this problem, and that was to multiply both sides of one of the equations by -1. Now that they're opposites, I'm going to draw my line and add them together. When I add them together, 6x minus 6x is nothing. The x's were eliminated. 9y minus 5y is 4y. Let's bring down the equal sign. And then -3 minus 9 is -12. To finish getting y by itself, I want to get rid of multiply by 4. So let's divide by 4. And then finally, my y is by itself, and -12 divided by +4 is -3. So just like the last one, I want to take my answer and substitute it back into one of the original equations. It does not matter which one of the original equations I grab. For no particular reason, I just grabbed the top one. Okay, but it doesn't matter which one you plug it back into. So I'm going to replace this y right there with -3. So I've made some space, that y, put a set of parentheses. Now let's insert -3. Before I start moving letters to one side, numbers to the other, I need to simplify my equation. I want to simplify the left side. I can take 9 and multiply it by -3, and that gives me -27. Then I'll bring down the 6x and bring down the equals -3. Now that it's simplified, I'm ready to move letters to one side, numbers to the other. So let's move -27 to the other side. So the opposite of -27 is adding. What I do to one side, I do to the other. The left side still has 6x. Bring down my equal sign. -3 plus 27 is 24. Get rid of multiply by 6. So let's divide by 6. X is by itself, and +24 divided by +6 is going to equal 4. Just make that a little smaller so you can see that. Okay, so it equals 4. And if I was to graph the original two equations, those two lines would end up crossing at the point 4, -3.